have
Yeah.
cotangent is down to the right. So my teacher always does draw your shape, which I actually kind of like. It helps a lot drawing the shape because then I don't mess up. It helps your graph a lot. So down to the right, we have we can rewrite the equation is rewritten as y equals cotangent bracket I can't, your hand's kind of covering, so I don't know what it is. Factor out the 3 parentheses theta minus 5. What is it? 5 pi over 2.
5 pi over 2, yeah.
Times 1/3.
Mm-hmm.
So we have 5 pi over 6. And then our vertical shift is up 1. So now that means our midline is at 1, our max is 4, and our minimum is -2.
Yeah.
Okay.
Good.
The period is B is cotangent is just pi over B, so it's period is pi over 3. Increment is pi over 12. And we have a phase shift to the right, 5 pi over 6.
That's right.
Okay, so the graph is really where I can get all that, but the graph is so it starts at 5 pi over 6, but because don't you go by increment is your tick marks, and then
let me right. So maybe if I do this, it's going a little too slow for you, but let me kind of just show you how I go about it.
Okay.
And then you can kind of pick and choose which way works for you. So I create a table with all the information that I have. Now with cotangent, your cotangent parent graph is going to start at 0, right? And I'm not going to do the phase shift just yet. I'm just going to get my table going. I know my interval is pi over 12, so I'm just going to add pi over 12 to each of my initial. And I'm just keeping my denominator to make it easier to add. Now, you say phase shift is to the right, 5 pi over 6.
Yes.
Which is, I'm going to be adding 5 pi over 6. I'm just going to make it so that it matches all my denominators. So I'm just going to make it plus 10 pi over 12. Right, it's the same thing, right?
Wait, what'd you do?
I found common denominator to match all my denominator initially, so I made it 5 pi over 12.
So you started with pi over 12 plus 2 pi, or these your okay.
So this would be what my graph would, where my location would be without the phase shift.
Yeah.
And now with the phase shift, I'm going to add 5 pi over 6. Now, I guess, if you have your calculator, you don't have to, you just make it calculate, do all the work. But I'm just going to say plus 10 pi over 12.
Okay.
Does that make sense?
Yeah, no, I see what you did.
Okay. I'm just about to make all my points shift to the right here. Okay, and then 0 plus 10 pi over 12 is just 5 pi over 6, or 10 pi over 12.
All right. And then you have 11 pi over 12. And then isn't that 12 pi over 12?
Which is pi.
And then you have 13 pi over 12. And then you have 14 pi over 12.
Now I'm just going to reduce that to be 7 pi over 6.
Yep.
Okay, now you said that cotangent has a downward shape, and so, but I still like this 5-number system. I'm going to be bookending my cotangent with vertical asymptotes, undefined.
Okay.
And then my Original cotangent graph will be 1, 0, -1. Right.
Where are you getting the 1 and the 0 and the -1?
So your original cotangent graph is,
The parent.
the parent graph is going to be starting at 0, and it's going to be, going up 1 and then down 1 on either side, right? Because your original cotangent graph just looks like this, right? You have vertical asymptote, +1, 0, -1, and then vertical asymptote.
Got it. All right.
Now there is my A value is just 1, so I don't have any vertical stretch, right?
Yep.
You said.
No.
So my vertical asymptote will stay, but my D value is going to push my graph up 1 unit.
What is D? What does D represent?
D is my so my A, B, C, and D. My A is my amplitude, or A is the A value is my amplitude. B is for my period, right? And then C is for my phase shift.
So D is your vertical.
D is my vertical shift. Yeah.
Okay. Yeah.
So yeah.
No, you're good. You're good.
And now all I need to do is to worry about my top row and bottom row. Those are my order pairs. That's going to go on my graph. Asymptotes on both sides. My midline is at 1. So 2, my first order pair that I'm going to graph is 11 pi over 2 and y value of 2. Next up, pi, y value of 1. And then 3 pi over 12 or 13 pi over 12, my y value is at 0. And here's my graph.
So, I mean, I get the table, but like I just have never done the table, so it's honestly more confusing for me.
Got it. Okay. Well, we can adapt to however way you want. I guess your question was how we get these numbers, right?
Well, yeah, kind of. I know it's your first. My teacher says your first point is at your phase shift.
Okay, sure.
And then after that you just add the increment.
Yeah.
And so right. You get that's what we would have gotten, but I'm kind of confused about labeling the points. Like so I know the vertical asymptote is at your x's, it's your 0 and your period. So one of them would be at 5 pi over 6.
Mm-hmm.
One of them would be at 7 pi over 6.
Yeah,
right?
That's right. Mm-hmm.
So what does that look like on the? Where is that on the number line? Where is that on the? Oh, it's all the way at the.
Yeah, so I have it at 5 pi over 6 here, and then I have it at 7 pi over 6. So I just made 5 tick marks, and I know my first and last tick mark will always be my asymptote, and then my middle points will just be my order pairs.
Okay. If we weren't doing the order pairs, I'm trying to remember how we find the shape. So it goes. Let me think. Code.
Yeah. So your cotangent initially, without any phase shift or vertical shift or amplitude or a vertical stretch, your order pair will just be your y values would be just 1, 0, and -1. Right. That's what your parent graph looks like for cotangent.
Okay. Yeah, but what about the I thought on this graph it would be 1 at 4, 1 at 1, and 1 at -2.
Why would you say that?
Well, because I thought that's what we drew out the little shape we drew out because of the there was no my fault, there was no Yeah, you're right. There was no vertical.
Yeah, there was no number in front of cotangent, right? If there was a 3 out here, then that may change things a bit.
The 3 for the B. I don't know why I thought that, but I was thinking the 3 for the B. So it would just actually be, hold up, yeah. It would just, the highest point is 1 and the lowest point is -1.
Highest point is right. That's right. Yeah, you're right. For the parent, that's right. 1, 0, -1, right.
All right, give me 1 second. All right, so then we'd have a point at, yeah, I got it. Yep. I was just thinking there was a vertical asymptote or vertical stretch, I mean. All right, Can we do the next one?
Now we need to be able to write out asymptotes as well.
So, I got the asymptotes. X equals 5 pi over 6 and x equals 7 pi over 6.
But you have to create a rule that will allow you to increment all the asymptotes. You got to create a rule for it. So the way that I say it is 5 pi over 6 plus whatever that distance is between 5 pi over 6 and 7 pi over 6, which is pi over 3, right?
Wait, so between 5 pi over 6 and 7 pi over 6 is
2 pi over 6.
Yeah.
Which is pi over 3. So that means I'm going to increment by pi over 3 n to indicate that if I keep adding or subtracting pi over 3, I'm going to be able to keep hitting all these asymptotes.
I have never seen that. Okay.
Oh, really? Okay. Well, then if that's the case, that's how my students do it. That's how I showed on the key. But if you didn't do it, then you can just list out your asymptotes.
All she makes us do is like for cotangent, it's just you have to either subtract or add the phase shift to the 0.
Yeah, okay. I thought that like if you were writing domain, that you would have to list out a rule.
Probably is helpful to know domain if I have to look for domain and range. All right. Can we do number 2?
Okay.
All right. So number 2 is your vertical stretch 2. 2 secant. Is that so pull out?
Oh wait, my bad. This is a mistake.
Yeah,
if you can rewrite this equation, it should be y equals -2 secant pi over 2.
Wait, so how does this one work? How would I get out the 2 in the pi?
Okay, so what you would do is, well, you know that pi over 2 is going to have to come out. So let me cross this out. This is not the one we're going to do.
Is the equation wrong?
Yeah, the equation is wrong. So
okay, so don't you just pull out 1/2 pi?
Yep.
Okay, so pull out pi over 2 and multiply. What was the original pi over 3 multiply pi over 3 times pi over 2
times 2 over pi.
Oh yeah, to cancel. Wait,
to cancel it out, right?
But I thought,
because just like over here, right? If I pull a 3 out, I gotta multiply by 1/3.
Yeah, I got you. So then it would be 2 over 3 is your.
That's right. Yeah.
All right. So now that we have that, I'm gonna draw the shape. Would be its midline is at. Well, this is a secant, so the opposite of it's an upside down. It's an upside down cosine. I know you're not supposed to. Well, I do it as I draw my cosine, and then you know what I'm saying. Find it out.
Yeah. That's what I have my students do. Draw the cosine and the asymptotes, and then your secant will be easy.
Okay, so the midline for this one's upside down. It's the midline's at 1. It goes highest point's 3, lowest point is -1.
Okay.
And so I need mostly I mean, this graph doesn't really matter because sometimes you have to shift it to be more negative x-axis, and I mean the phase shift is negative. It moves. Your first point will be at -2/3.
That's right, -2/3. Yeah.
And then my increment is pi/8. Right?
Your
Isn't
increment.
What is it? I thought it was b divided by.
It's
Oh, it's period. Is it period divide? Yeah. Okay.
Yeah.
All right.
So my increment is 1, right?
Yep. So b was 4, and then increment is 1. So start off at -2/3, and then my increment is 1. So you go to 0 is another point, and then I add 1, so I get 1. Is that how you do it? I don't. Sometimes these ones confuse me with the increment starting in the negative.
So yeah, I'm going to keep adding 1, and that will help me get to all my other x values. So -2/3 plus 1 would be 1/3.
Okay. 1/3.
Plus 1 would be
4/3.
Mm-hmm.
Or wait, what am I? Yeah, it would. Okay. And then plus would be 7/3, and then you'd get 10/3.
10/3, yeah.
And you're good there. So, and now we can start the midline.
Start the cosine.
Yeah. I was drawing my y-axis things. My values for the y-axis. I got 1, got -1. Then you got your high point at 3. So it starts. Your first point is at -2/3.
Where are your asymptotes?
Usually I do my asymptotes at the end once I see where the midline. It would be at 1 and 1/3 and 7/6. So
I have it as 1 at 1/3 and 7/3 because that's where the midline intersects the cosine. Yeah.
That's what I meant. I said 1/3. I don't know what I said for the second one though. I think I said 7/6, but
7/3.
Yeah. So first point is the lowest point on the cotangent, and then secant graph or the cosine graph, and then you got one at on the midline at 1/3, and then another one at the peak at 3, 4. It's at 4/3 at 3, and then another one. It comes back down to the midline at 7/3, and then down again to -1 at 10/3.
Yeah.
Okay.
Now we can draw in our true graph, which is the parabolas that kind of resemble, or that represents our secant graph, right?
So I know that sometimes I get confused. You know when you kind of draw the half parabolas?
Mm-hmm.
So that's the only one I kind of struggle to remember, like to make sure it's facing the right way, if you know what I'm saying. Like,
yeah.
So how does that work?
So your parabola will always kind of reflect and bounce off of the peaks and valleys of your cosine graph. So if your cosine graph is facing downward, then your parabola for your secant is going to face upward.
Wait, can you say that again?
So you see how this cosine has a peak?
Yeah.
And it kind of looks like a parabola that's opening downward.
Mm-hmm.
So I'm going to create a reflected version of this where the parabola is going to now open upwards, and it's going to kind of kiss that peak of my.
Oh, yeah, no, I know that one. It's the like the ones down there that kind of get me The one that it's like at the one that runs from 2 over
Right. 2/3. So I don't see the asymptotes on this side, but I know there's an asymptote here, right?
Yeah.
So I know that technically there's a parabola that's opening down,
Mm-hmm.
but from the peak, I'm only going to show half of the parabola. So I'm just going to make it show half of my parabola opening down.
Got it.
Same thing over here. I have an asymptote here. I got a valley. So from here, I can start here and I can create half of my parabola. I'm just not going to show the other half.
Makes sense. All right. Could we do a tangent one?
Yeah, I got a tangent on the next page.
Sounds good. All right. Can I see the equation real quick? Just write it down.
Uh-huh.
All right. 3 tangent. All right, you're good. Thank you. I know you're supposed to, whenever you do it, you have to multiply by the reciprocal, but wouldn't you have to multiply by the reciprocal to get out 1/2 in the first place? So why wouldn't B be 2? You know what I'm saying?
Yeah, that feels a little bit confusing, right? It's like, why do we do that?
Yeah.
Well, here's the big picture. The big picture is that whatever you do, whatever you end up with, you should always be able to redistribute and get back to your starting point. I think that's an easier way to think about it. It's like, okay, whatever I do, I just have to be able to get back to my starting point. If I get back to my starting point without any issue, then I know I'm correct.
All right. Got it. So if it's a tangent, it's up and to the right. So it's a little bit like do my little sketch, and then the midline is at -1, highest point is at 2, lowest point -4. So it's gonna be mostly I'm gonna need more I'm gonna need more like negative for this. Yeah. And then
okay, yeah, that's right.
Where should I put my x-axis though? Like should I do more in the center or like?
Well, this one is starting at
more over to the left because it's gonna be at it's gonna start at 8/3.
Now, do you do it this way where if I want to see that full graph, I start at 0. I let the 0 be the middle, and that way I can see the negative and the positive side, or no?
What do you mean? Do I let it start at 0?
Because if I start my tangent at 0, it's going to look a little strange. It's going to kind of look like this.
Oh, no, I don't really do. I just kind of generally guesstimate my graph, like get my graph done, get my y increments, and then get my y values, and then like find my increments, and then I just kind of like find the points based off, because I have a little doodle on the corner that's just like 2, -1, -4, so I know where the points have to go. So I don't really think about the 0 very much. If that makes sense. That might have been a little confusing, but
yeah, I mean, as long as your graph is right, I just want to make sure that that you either understand that your graph, if you want to see your tangent graph, you can either have it go through the origin and have negative and positive on both sides, or it can completely shift, pi over 2 and then build out from there.
okay. I feel like I usually shift first.
Okay. All right. So you can just walk me through how you do it.
Okay. So I start and put down 8 pi over 3, and I'm adding my b is, or not my b, my period is 2 pi.
Mm-hmm.
And then I do divided by 4, so you get pi over 2. So I'm going to add pi over 2 to 8 pi over 3. But I'm going to try and make them like denominators. So this one's actually going to be kind of messy.
Now, are you making 8 pi over 3 your starting point?
Yes, because don't you start at the phase shift?
You do, but if you start at the phase shift, okay. So the big thing I think you have to understand is that your cotangent is nice, right? Cotangent is going to start, if you start at the phase shift, that means you're picking up your asymptote and you're moving everything along with it.
Okay.
Right. Picking everything up, moving along with it. But if you are doing the tangent and you want to pick up, and if you want to start at 0, your graph is going to be offset. It's not quite as clean as the cotangent, because if my parent graph, it's going to look like this.
Okay.
Does that make sense? So if you want to start at 8 pi over 3, you can. It's just that you're picking up the middle of the graph and you're moving it. You're not picking up the ends of the graph and moving it. So as long as you're okay with this shape and moving it left and right and understanding your graph's going to end up looking like this and not like this, then that's okay. But just understand that if you want to start here and you want to move it, it's not going to look like this. It's going to look more like this.
All right. So what do you think? So I'll do what you think we should do.
So this is what the parent graph looks like. Okay. This is tangent without any changes. Okay. This is what tangent looks like. So
okay.
Tangent looks like this. Let me just do the table again, just so you can kind of see everything. Tangent without any shift, without anything. This is why I tell my students, I say, hey, let your 0 start in the middle, because that way you can feel like you're bookending your graph with asymptotes. And then your period is pi, right? So if I do pi divided by 4, then that means I'm adding pi over 4 on both sides.
Wait, why'd you put it at that specific spot though? You know what I'm
At
saying?
0?
Well, you did pi over 4, but I don't know why it was important. Like,
oh, okay. Why it's important? Well, that's what let me show you what tangent looks like. How's that? Let me just look up.
Yeah,
show you what tangent.
Hard one for me. I feel like it's the most difficult one. So I understand you put the 0 in the middle, but then why'd you do? Is that the parent function? Like,
yeah, this is the parent function right here. Negative pi over 2, negative pi over 4, pi over 4, and pi over 2. So -1, 0, 1. This is what the parent graph looks like for tangent.
Okay.
If you want to start at 0, it's going to look like this. It's going to feel like you start halfway through the cycle and then asymptote, and then you're finishing off like that. Which typically, I mean, that's fine, but it just looks weird because you feel like you got cut off. You're starting halfway, you're cutting yourself off, and then you're finishing up the first half.
Okay, but could I just find my asymptotes first? Like, couldn't I just, because aren't the asymptotes, isn't it, what are they for, Can? Isn't it period divided by 2?
Period divided by 2. Yes, that's right. That's where your asymptotes will be. It'll be at pi over 2 and at pi.
Okay. So how should I go about doing this one then? With what I have so far.
So with what you have so far, then what we can do is just understand that you're going to go to the left and to the right of your phase shift. So wherever your phase shift is, pretend like that's the center of your graph, and then just add your increments to the left and to the right of it.
Okay, so pretend like 8/3 is the center of my graph.
That's right. Pretend 8 pi/3 is the center of your graph, and then just build out on both sides.
Okay, so should I do minus? What should
That's
I do?
right. Then you do minus pi/2.
So if I minus pi/2 from that, what is that? I need to make them both like denominators. So
I think you get to use your calculator, right?
I don't know. Are you allowed to use calculator?
As long as it's non-graphing calculator.
So you think
that's what?
Or do all the AP precalc teachers do the same kind of things?
I believe so, because on the on the instructions for the previous quiz, it just says no graphing calculators.
Is this 2.18 quiz tomorrow?
Mm-hmm.
Okay, yeah, it says
2.12. Yeah, 2.18. I guess I changed that number a bit. But either way, I mean, it's not going to be hard, right? With or without a calculator. So
yeah, it's just easier because you save time not having to.
Yeah.
So it's 8 pi/12 minus pi over.
Well, the phase shift is 8 pi/3.
Right? Oh yeah, you're right. Sorry. So 8 pi/3 minus
pi/2.
So then I get 13 pi/6. How many do I need to move each way? 2 each way, right?
2 each way, right? That way I can bookend both sides with my asymptotes.
All right. So I do that. Then I do negative 13 pi/6 minus another
pi/2, which is 3 pi/6.
Wait, minus another? It's 3 pi/6?
Because isn't 3 pi/6 same thing as pi/2?
Oh yeah, you're right. I thought you were saying that was the final. Well, because in my calculator I did negative 13 pi/6 minus pi/2, and I got 8 pi/3, negative 8 pi/3.
So you said the phase shift was 8 pi/3, right?
Yeah.
So that's going to be the center of my graph.
Okay.
So then do 8/3 minus 1/2.
Yeah, that's what I thought we did. We did 8 pi/3
minus 1/2
minus. I don't know why it's giving me decimal form. Hold up.
So you can also do it this way. Common denominator, 8/3 is 16/6. 16/6 minus 3/6 is 13/6.
Okay. Yeah, no, I got that. Negative 13/6, but isn't it negative because I'm going to the left? But are you doing positive first?
Well, 8 pi. Okay. If I start at 0, then I'm going to be in the negatives. But 8 pi/3 is further to the right. So if I subtract pi/2, I'm still in the positives.
Okay, I got it. 8 pi. Yeah, you're right. Okay, so I'm still in the positive at 13 pi/6. So then I do another minus another increment.
One.
Yeah. pi/2, and then I'm at 5 pi/3.
Right, which is the same thing as 10 pi/6. Okay, that's fine. And then now from your center, you're going to add pi/2 twice more on this side.
So now I'm adding it instead of
That's right.
8 pi/3 plus pi/2 to get 19 pi/6. And then plus another. Yeah, I was just typing it in wrong to the calculator. It was confusing me. And then I get 11 pi over 3.
Yeah, so that's the only thing different with tangent is wherever your phase shift is, don't let it be your first point. Let it be the center point, and then just build out the rest of your 5 points.
Yeah, that makes
using your interval, right? That way it's clean. Now you're going to be able to bookend both ends of your graph with asymptotes.
Okay, so would my y-axis go straight down 8 pi over 3?
No,
right?
Your asymptote is going to go straight down
So
5 pi over 3 and 11 pi over 3.
Yeah, no, I know, but I said my actual y-axis. Like when you do your graph, you have the y-axis goes down, or is there not a y-axis for this one? Am I?
Okay, well let's sketch the graph.
Just draw it out, because on mine I have it. I have the asymptotes in the right place, but I'm just curious where the.
Yeah, so okay. This is 5 pi over 3. This is 13 pi over 6. This is 8 pi over 3.
Okay, so it starts. So this is all going one way. All right, yeah. Okay, yeah.
Yeah, because everything got moved up and shifted right to 8 pi over 3, right?
Yeah. What's the highest this graph goes? The graph.
My midline is at -1.
-1.
I'm going to go 3 above it and 3 below it.
3. Below is. All right, so it's tangent graph up and to the right. Isn't that how these work? Up and to the right. So my lowest point is at it's at -4 5 pi over 3. Or actually, no, it's not. No, it's not. Because that's my asymptote. So it's at 13 pi over 6 at -4. Then 8 pi on the 8 pi over 3 at the midline, and then at 3. Up at 19 pi over 6 at 3.
At 2.
Is it at? Well, I thought it's -1. Oh yeah, you're right. At 2. So, all right.
Yeah, so I think you got it. You just have to remember with tangent, whatever your phase shift, force it to be your middle point, and then you can just subtract your interval from both sides, and that way you can get your graph to be clean.
Yeah, I liked your way a lot better.
Everything else you can start your phase shift at as your first point to the left, except for tangent. Like, yeah, just make tangent start in the middle.
Got it. All right, can we do one more tangent? I like these ones are the hardest ones, and I want to see if I can get the next one right.
Okay. All right. Let me create one here.
The equations are pretty easy in my opinion. All right, so
oh wait, sorry, what if I made it a negative here?
Nothing really changes except it's instead of going up to the right, it's going. Isn't it going down to the left? Isn't it look like
Yeah, it's gonna look like cotangent.
Yeah, it kind of is confusing with the tangent ones how they're gonna look though. Like, so if it's so normal cotangent goes
like
down to the
this.
right. Wait, I thought
Normal cotangent goes down to the right. Normal tangent goes up to the right.
Okay, so then normal tangent goes up to the right. So negative would go up to the left, or how'd it go?
It's gonna be reflected. It's gonna now look like this.
All right. Can you like write which one's which? Because it's kind of
Mm.
so that one's tangent, and then I mean, couldn't I just tell when I do my plot though?
Yeah, for sure. You can just you can just graph all your points as tangent and then just change the sign and then it'll turn into that.
All right. So you said let's start at our let's find our period. So it's pi over b. So pi over b equals 1/3. B equals 3 pi. Our increment is 3 pi over 4. And our phase shift is to the right 3 pi. So, and we have the vertical midlines at 3. And if the midline's at 3, the max point is at 5, lowest point is at 1. So sketch out the, let's make, you said make 3 pi the center. So we have 3 pi as the center. We add, let me add it real quick. We add 3 pi plus 3 pi over 4 to get 15 pi over 4. Do it again. You get 9 pi over 2. And then subtracting from 3 pi, you get 3 pi over, you get, wait, what? You get 9 pi over 4, and then subtract it again, and you get 3 pi over 2.
Yeah.
And your axis and your what's it called is going to be at
midline, right?
Yeah.
No,
I was thinking of vertical asymptotes, but yeah. Midline will be at 3.
mm-hmm.
Is it like okay if I start I don't need to like shift it up? Like, can I just start it at and write that as my 3? Like, do I need to move it necessarily? Like, do I have to put those ticks to indicate it's up 3?
No, as long as you label everything however way you
Like,
want to. You want to label that as 3, you can do that.
Like right now, I just have it as like I drew the graph and I just put 3 as like where 0 usually is, and then I'm just gonna tick up to what it is.
Sure, that works.
That's not like okay. And then
as long as you label everything, you can do it anything you want. Yeah.
So it's gonna our vertical asymptotes are gonna go through 3 pi over 2 and 9 pi over 2. Obviously, the one is going to be in the middle, and then one's going to be at 5, 9 pi over 4, and then 2, 15 pi over 4. I actually like this method of doing it. All right.
Is that what you got?
That is what I got.
Okay.
The only thing is, mine looks like 3, but I labeled all of them like.
That's right. Yeah. If you label everything, you're good. It doesn't matter if it looks like the x-axis.
Yeah. All right. Yeah, I think I'm good.
You want to do this one here, write the equation, or you think you're good with that?
Well, we might as well do it. So it's, because I did, the cotangent ones are a little more confusing. So it's y equals plus or minus cotangent. Period is pi over 6. So then don't you have to, wouldn't I reverse it by equals? How would I backtrack from what I do as?
Yeah, I just use the formula just to make it easy.
So you do pi over b equals.
And I just cross multiply and I solve for b.
But invert. Okay. So then I get 6 pi equals b over. So then you get b is 6. So you get theta. What is it? That is shifted, or is there a phase shift and left? So it's plus 9 pi, parentheses, bracket, plus 3. Yeah. What else? We could. I don't know. It's not that bad now that I know that the tangent thing. It's not. That was the only kind of hard one.
Yeah, that's the only hard one. That's why it was last, because it was had the most parts to it.
Yeah, but I like the way you described it.
And you're good with secant?
We can do one secant if you want, real quick.
I'm sorry, we did do secant. I meant cosecant.
Sure, let's do cosecant.
Okay.
I can't see the. I can only see you, Mr. Yang.
Oh, really?
Yeah. Mrs. Yang. Mr. Yang.
Hey.
So I don't know what happened.
Yeah. Let me get this up here.
Yeah.